All right, if you're a software tester, especially in telecom, let me ask you something. Have you ever been in one of those meetings, the one, where the conversation just takes a nosedive into all this network jargon? It can get pretty confusing, right? Well, in this explainer, we are going to clear all that up. We're going to demystify the key network components you absolutely need to know. And we're pulling all our insights from the fantastic book, Telecom Testing Simplified by Atul Sharma.
I bet this sounds familiar. You're in a defect triage meeting. You've described the bug perfectly, and then someone chimes in with, sounds like it might be a router issue. Or, did anyone check the firewall rules? For a lot of us testers, that's the moment where the conversation can suddenly feel like it's happening in another language.
And if you've ever felt that little drop in your confidence right then and there, you are definitely not alone. It's a super common feeling. But listen, the goal here isn't to turn you into a network engineer overnight. No way. The goal is to give you just enough knowledge so you can feel confident, understand what's being said, and actually contribute to that conversation in a meaningful way. So how are we going to do that? We're going to use a really powerful but simple mental model. I want you to forget all those complicated network diagrams for a minute. Instead, I want you to think of your network as a city. Seriously, it's a simple analogy, but trust me, it makes everything just click. Just take a look at how well this maps out. A city has to manage the flow of traffic, right? You've got local roads, you've got highways, you've got security checkpoints. Well, a network does the exact same thing, but it's managing the flow of data. Each piece of the network has a very specific job, just like the infrastructure in a city. Okay, so let's meet these traffic managers of the network one by one. We're going to break down what they do, and this is the important part for us, what it looks like from a tester's point of view when one of them isn't working right. First up, we have the switch. The best way to think of a switch is as the director of local roads in a single neighborhood. Imagine you're in an office with a bunch of computers, servers, and printers. The switch is the thing that connects them all and makes sure that when you print a document, it goes to your printer, not the one down the hall. It's all about managing traffic that stays within that one local area. So, as a tester, how do you spot a switch problem? Well, you'll see failures that are very localized. Think about it. Two servers sitting right next to each other in the same data center suddenly can't communicate. Or an application can't connect to its own database, which is on the same local network. If the problem feels really contained to just one specific site or location, a faulty switch is a really good place to start looking.
Okay, next up is the router. Now, if the switch handles the local neighborhood roads, the router is the massive highway system that connects all the different cities. Its job is to take a piece of data from your local network, say in New York, and figure out the absolute best path to get it all the way to a server in London. It's the master navigator of the internet, using IP addresses as its map.
And for you as a tester, here is the absolute key thing to remember. Router issues are very often location dependent. This is a huge clue. You might see a feature working perfectly for your team in the US, but users in Europe are reporting that it's constantly timing out. If you ever see a bug that only seems to happen in certain geographic regions, ding ding ding, a router is a prime suspect.
So let's just nail this down because it's super important. Switch, local neighborhood streets, connecting devices right there. Router, the big highway system, connecting different networks or cities far apart. Just getting that one distinction straight is a massive step forward in being able to diagnose problems.
All right, what about a gateway? Okay, stick with our city analogy. Imagine a border checkpoint between two countries where they speak completely different languages. The gateway is the official translator at that border. In the telecom world, a classic example is a gateway that translates a voice call from the old-school phone network into digital data that can zip across the internet. Its whole job is to connect two totally different kinds of networks.
Now, gateway issues can be really tricky and subtle. For instance, a phone call might connect, but the audio quality is just awful. Or maybe data gets sent out just fine, but the response never seems to make it back. You'll see this a lot when you're trying to connect a new, modern application to some old legacy system. That gateway in the middle becomes a really common point of failure. Of course, every city needs good security, and in a network, that's the firewall. Think of it exactly like a security guard standing at the front gate of a very important building. They're checking everyone's ID. The firewall does the same thing for data. It looks at all the traffic coming in and going out and decides based on a very strict set of rules, you can pass or nope, you're blocked. It's all about protecting the network. And this firewall is the source of one of the most classic, most frustrating problems for testers. You know the one. A feature works perfectly in the test environment, But the second it moves to staging or production, it fails. The code is identical. So what happened? So often these mysterious bugs are nothing more than a firewall rule that someone forgot to update for the new environment.
Okay, so what happens on Black Friday when a shopping website gets millions of hits all at once? You can't possibly send all that traffic to a single server. It would just collapse. That's where the load balancer comes in. It's like a traffic cop standing in front of a stadium after a big game, expertly directing cars into 10 different parking lanes so no single exit gets jammed. It's all about spreading the work out to keep things fast and reliable.
Now listen up, because this is a huge tip for testers. If you ever come across a bug that feels completely random, suspect the load balancer. You try an action, and it fails. So you try the exact same thing again, and this time it works. What's going on? It's often because the load balancer sent your first request to a server that had a problem and your second request to a different, healthy server. That inconsistency is the #1 symptom.
Okay, we've met all the traffic managers. But how do they know where to send all the data? Well, they use an addressing system, and that's where we get to IP addresses and ports.
This is honestly the easiest way to picture it. Think of the IP address as the street address for a big apartment building. But just having the street address isn't enough, right? You need the apartment number. The port is that specific apartment number for the service you're trying to reach. You absolutely need both to get the delivery to the right place. And as a tester, this is critical because a bug isn't always in the code. Sometimes it's just a firewall that's blocking access to that specific apartment number, that port. And knowing to even ask that question can save you and your team hours of painful debugging.
All right, so now that we've met all the individual players, let's put it all together. Let's trace the journey of a single request from a user from start to finish. So imagine you click a button in an app. Your request starts a journey. First, the local switch gets it on its way. Then a router shoots it out onto the internet highway. The firewall at the destination checks its credentials to make sure it's allowed in. If needed, a gateway might translate it. And finally, a load balancer points it to the best available server. The key thing here is that a failure at any one of those steps can break the entire chain and cause the whole thing to fail.
And having this understanding completely transforms how you report bugs. Instead of just writing, "The login feature is broken," you can now provide so much more valuable context. You can go from making common mistakes to adopting a much more powerful, professional approach. And remember, you don't have to have the final answer. But now you can ask much smarter questions and describe the symptoms with way more precision.
And really, this is so much more than just learning a few new words. Understanding this data flow is like unlocking a new superpower for your testing career. It's what takes you from being someone who just follows a script and executes test cases to being a true quality expert who really understands the system from end to end.
There's a line from the book that I absolutely love, and it's this: recognition is enough to elevate your testing. That's so powerful. You don't need to know how to configure a router. You don't need to be a network architect. Just being able to recognize what these parts do and the symptoms they cause when they fail is enough to totally transform your testing and your confidence.
So, let's do a quick recap. What are the big takeaways? First, the city analogy. Always think of your network as a city managing traffic. Second, each component, your switch, router, firewall, it has one clear, distinct job. Third, and this is the big one for us, when they fail, they create specific, recognizable symptoms that you can now spot. And finally, knowing this stuff is going to make your bug reports clearer and your voice in those technical meetings a whole lot stronger.
So there you have it. With this simple framework, you are way better equipped to understand what's happening on the network, to ask those smarter questions, and ultimately, to find more important bugs. If you found this explainer helpful, please do me a favor and like the video, and be sure to subscribe to Enhance Smart Skills for more simplified telecom and testing concepts.